Hello everyone. Welcome back to another interesting video about A2A protocol. I have already created a video about A2A protocol and MCP protocol, but that's a short video which explaining the terminologies and why we need these two protocols A2A and MCP. I will give a link to that video below. But today we are going to deep dive into A2A protocol, agent to agent protocol, which is from Google. And we are going to see all the components and how these interact internally and what is the real world use case, how this agent to agent protocol can be used to solve a large operational or a large backend operation program, and then we will understand why this A2A protocol, also known as agent to agent protocol, is very important for the future agent AI systems or multi agent systems. We will also see a little bit how MCP is helping the agent to agent systems and why agent to agent protocol and MCP protocol is needed at the moment. Maybe in the future, if agent to agent protocol is extended with similar to MCP, might be we don't need the MCP protocol. Or if we use some other framework or some different architecture pattern, then also we may not need the MCP protocol. But at the moment, agent to agent protocol is the most promising protocol to build multi agent system from different platforms, different vendors, and different enterprises, business to business use cases, business to customer, B2C use cases. So stay tuned for what is an agent to agent protocol understanding. Now we are seeing a typical backend operation departments in any enterprises. It could have functions and departments like data entry, accounting, research, recruitment, IT support, order processing, marketing support, web support, front end department, like so. And each department and each function needs to be in communication with each other to fulfillment of their services. And we are going to see this scenario how multi-agent systems can convert it or can be used to automate this and their systems or some core functionalities of these departments, and how A2A protocols is enabling to create this multi-agent system which will automate the entire department for backend operations of a company. Now, in the diagram, I want to show you the representation used so that we can easily understand each components. So there are two agents represented in this diagram, agent 1 on the left side, agent 2 on the right side. And agent 1 belong to an enterprise or a company, and agent 2 belong to a vendor. So let's assume this scenario. And when I say enterprise and vendor, it's two separate concerns or two separate companies. They are located remotely, and they are two separate business. So they don't have anything in common. They have separate business. They might be using separate technology platforms. They might be using separate users and all. Okay, and this is the separation of concern in terms of design language, and we are going to see how A2A protocol used in this context. So if we look at each agent, we can see there are certain components for each agent, like local agents, LLM or foundational models, and a development kit. In the left side, which is a Google-based agent, it have Google Vertex AI and Gemini API foundation models, and it is also having Google Agent Development Kit, also ADK. But on the right side, let us assume that it's using open source tools. So the foundation model, LLM model used could be Cloud A or DeepSeek R1, and it could use any agent framework like LangGraph or anything like that. And when it comes to local agents in the agent diagram, it is not necessary that every agent will have local agents. So it's a logical representation. Sometimes a system have a supervising agent and many local sub agents, and sometimes it may not have. So maybe in the left side we have local agents, but on the right side, on in the different vendor company, we may not have any local agent. We just have one agent. Next, we are going to look into MCP protocol, Model Context Protocol. So in this particular scenario, where we have an agent in a company and another remote agent in a different vendor company, remotely located, the MCP protocol is used to call APIs and enterprise applications for respective company. That means the agent one on the left side will use the MCP protocol to get the APIs from its mother company, while on the right side, the company B, agent B or agent 2 will use MCP protocol to get the APIs from that company, the company number 2. And also the MCP protocol can use to get the public APIs specifically for agent 1. Similarly, MCP protocol on the right side will use public APIs and data for agent 2 on the right side to fulfill that agent 2's task. As you can see in the image, there is a barrier, a complete barrier between agent 1 and agent 2, the agent on left and agent on right, and the MCP protocol cannot be shared between these agents in this remote agent concept. Finally, now let's see A2A protocol. So A2A protocol or agent to agent protocol is used to communicate between agent 1 and agent 2 on the left side and agent 2 on the right side. This is a logical representation. This means the agent to agent protocol is used to communicate between multiple agents. So agent could be in different locations, remotely located. Agent could be in different companies, partner companies or vendor companies or even the competitor companies. And agent can also be a locally hosted different agents. And each agent will have a task. Depending on the problem we are solving, it will find the agents and it will communicate with, and each agent, once it is finished, it will send back the response. We are going to see how A2A protocol works in communication wise in the next steps. Next, we are going to see A2A protocol or agent to agent protocol communication process. The process starts with an agent discovery. The client agent, in our case, the agent on the left side from the enterprise or company, starting an agent discovery for its process, for its task to complete. Once it's find a remote agent using the agent card, the agent card is the address of each agent with its capabilities and the task and type of responses it support. The agent will initiate, the client agent on the left side will initiate the task to the remote agent, which it is found by the agent discovery, and the remote agent will do the task execution. And once it is executed, the task completion, if it is error, the error message will pass to the client agent which initiated the task. In this scenario, each task is tagged with a unique identifier so that the message and the response can be transferred. As we see in the communication process of A2A protocol, the first step is the agent discovery. We will do a detailed video about agent discovery later because there are many scenarios and many methods are available for doing the agent discovery. But in this video, we are just explaining what is agent discovery. In order to find a client agent or a company to perform a task, it will look for remote agents. And remote agents can be found by a JSON format card called agent card. So each remote agent will publish the agent card, which is in the JSON format, which is readable by the client agent. And the client agent will decide which remote agent should be selected for the task completion. So in this example, I have an invoice agent and a front desk agent. So if the client agent wants to do a front desk task, it will select the agent, remote agent in the bottom with the red tagging. While if it is one day finance invoice task, it will select the top level agent denoted with the blue tagging. If there is multiple invoice agents selected, it will look for the security mechanism it supported, it will look for the UI mechanism it will support it, and different maybe the cost value it is supported. But the client agent will take the decision which remote agent should be selected for the task execution. Now let's go through the complete communication process. As we see in this communication diagram, the client agent on the left side discover or search for all agent cards available to it, which is the remote agent's agent cards, and it will identify the correct or suitable agent for the task execution. Once it is identified the remote agent, it will send a task request to the selected remote agent, and the remote agent will execute the task. In this example, the remote agent 2 is being selected by discovering the agent card of remote agent 2, and the input to the remote agent from the client agent is passed in the format of messages. Once all the task is completed, the final result is sent back to the client agent from the remote agent 2 with a special tagging called artifacts. Okay, that is also a special type of message, but artifact is used to send the response from the remote agent to the calling agent or client agent. In this diagram, it shows the internal technical working of this entire communication protocol. So the agent discovery is happening by sending an HTTP request to a well-known agent.json agent card. And once it is find the remote agent, it send the task initiation method using send subscribe method, and the remote agent will execute the task, and it will pass the response back to the remote so the local client agent using the state and artifacts. If it's a streaming type of task, that means a long running task, then the state is working and final equal to false. If it's a simple task which is immediately finishing, then the state would be completed and artifacts is stored in the result, and final stage equal to true. And in the case of a streaming task, the state will change to completed and final equal to true if the streaming or the long running task is completed. Now let's go back to the use case we selected for this multi-agent system. So the operation department or the backend operation of the company can be converted to a multi-agent system. Each department or each functional unit can be implemented using a single agent or a multi-agent supervising agent system. And the agent-to-agent protocol is used to communicate between the departmental agents. Likewise, the employees in department is communication between to fulfill their functions. Agent will also communicate between the agents to fulfill their task in order to complete the multi-agent system. Now the MCP is used for individual agent to complete their task to get external data either from their parent company or from the public domain, or to use the actions in their enterprise applications. Now I want to tell you one other scenario, a business scenario. In earlier times, the backend operation used to outsource to a cost-effective locations or an offshore center. But now we are going into a situation like instead of outsourcing to an offshore center, now a backend operation could be outsourced to an agent operations. So it could be a company but which much cheaper with less employee count, or it could be the company itself will develop a system, a single time investment. It will develop a agent system, and all these tasks backend operation will be outsourced to these agent systems. So think about this scenario, how this will impact our personal, business, and professional life, and then think what steps we need to take to make sure we are not behind this AI movement. If you like this video, please subscribe to my channel for getting the most updated videos about AI and agentic AI. If you want to support my work, please like and comment and share this video. I will come up with more advanced, detailed videos in agentic AI development, how this is progressing in the business world.